So the next question I'm going to give you some guidance on is question number 7. You are asked for an isomer with a different functional group than the ester ethyl ethanoate. First of all, to have a look at the naming of this, eth means 2. Ethyl relates to this part of the molecule where there's 2 carbons in a chain. And ethanoate also, there's 2 here. Your molecule is named slightly differently. Remember that you can use the chemistry generate structure from text. If you type in the name into Biovia, it will produce it for you, which is quite useful when you're doing this assignment. What I do is applicable to your molecule. I'm just using a slightly different one as an example here. So if we want an isomer, but we're not maintaining the functional group, we want the same number of and types of atoms in each isomer, but we're going to move them around in such a way that the functional group is not the same as it was before. Here it's an ester. We can recognise that because we've got a carbon double bonded to an oxygen and the same carbon bonded singly to an oxygen with some further carbon there. You can recognise that as the ester on our functional group charts. So this one needs to have the same number and type of atoms, but it's not going to be an ester. The easiest way to do this, I think, is to think about the fact that a carboxylic acid is very, very similar. If we get rid of a carbon and another carbon here, we have to add them on somewhere else, and we could add them on here, either as 2 branches or in a linear way. It doesn't actually matter. And then if we just show our explicit hydrogen there, what we have got is now we've got a carboxylic acid functional group. So we have a different functional group, but we still have 1, 2, 3, 4 carbons and 1, 2, 3, 4 carbons. If we counted up all the hydrogens, maybe, bear with me. I think you would have to do it in a linear fashion actually for this to work. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Actually, you have to do it branched for it to be an isomer for the number of hydrogens. That's interesting. So we end up with this, a new isomer with a carboxylic acid functional group, a different functional group. This is wrong, by the way, this formula. Don't worry too much about it. I've just copied it over and it's not quite right. This still applies what I've done with the molecules here.